All right. Looks like we've got a little bit of a bigger crowd today. Adam, I think your project is going to be popular. All right. I'm gonna quickly just get through the two new pull requests that are in here. We seem to have slowed down a little bit this week. We've got uh, one new one from Radic that improves string processing on the right path, and it's I think a relatively small change, but a win. So I think everyone's in agreement that it looks good. And there was also just a little bit of movement on this librd shared persistent read-only RBD cache work. It sounds like maybe there's some new code coming, so we'll see about that. Otherwise, a couple of folks have reviewed it, so I think there's probably still more to come. But yeah, that's about it. Not a whole lot of other stuff going on that I saw anyway this week. Um, all right, well, let's see. Blue Star in real life review. Okay, Nick, how quick is your quick Blue Star in real life review?
Um, Assuming there's no lots of questions coming through, probably only a couple of minutes.
Okay, Adam, would you mind horribly if I got Nick's thing out of the way so that we can just kind of have a big chunk of time for yours?
Not at all.
Okay, Nick, why don't you go ahead, and then we'll once you're done, then we'll move over to Adams.
Okay, sure. Right, do you have that on your screens?
Yes.
Okay, excellent. So, probably for a couple of months now, one of the clusters I've upgraded to BlueStore. And I know you guys are always really interested in how things are working outside of, I guess, benchmarks and stuff. So I thought I'd just sort of give some feedback. So the good is everything seems to be working really well. We haven't had any hitting any bugs or anything. We're getting about 1.5 times compression, which is really good. EC overwrites are good. We want to take more advantage of that. Our SSD predictive wear has completely changed course, which is really nice because some of them were starting to show that they might need to be replaced before we thought they were. SSD sort of only SSD pools are performing much better due to no double write, so that's been really good. And there hasn't been any fun in inverted commas with all the caching entries with large disks and stuff that you have with FileStore. I also suspect that snapshots seem to be a lot better with like RBD. I'm guessing because BlueStore's doing something more efficient under the hood than copying 4 meg files between folders. So that's all the good stuff. The bad, I've seen some sort of quite poor performance in some use cases, which is sort of why I wanted to sort of like highlight some of this today, to just get some sort of feelers out there for what people think. So from what I can see, the deferred writes, which is what's meant to write objects into the SSD on BlueStore, and then sort of commit to disk later, doesn't seem to apply to new objects. So for example, if I run a Rados bench with 4K objects on a FileStore cluster versus BlueStore, I'm seeing a difference between 1 millisecond average latency, say on a FileStore, to well over 10 on the BlueStore. Although this behavior is really only sort of synthetic, because during sort of real life, you don't really get to see this a lot. But that the whole deferred writes for not new objects does seem to be a bit of a performance drop. Probably the biggest thing I'm seeing though is with sort of mid-size writes, so the sort of the 64 to maybe half a meg size. So where file store did a really good job of sort of coalescing these and sort of buffering them in the journal, and then writing them out to disk in an efficient manner. With BlueStore, once you go over that deferred write threshold, everything's basically relying on the speed of the underlying disk, which in my case is 7.2K. So we're seeing latency go from a number of 2 or 3 milliseconds of say the NVMe up to maybe 30, 40, 50 milliseconds. So for sort of synchronous client writes, that's a very large drop in performance. And due to the lack of coalescing, I'm also seeing a lot higher disk utilization. So where the application is effectively streaming in these synchronous writes via NFS, and it seems to be very similar between RBD and Cephfs. I was typically seeing the disk utilization under 10% because FileStore was coalescing lots of these little writes into a big, multi-meg size IO and just doing one write at a later date. Large writes, though, are pretty much okay. So if you really try and do a synthetic benchmark with a hard disk and an NVMe journal, obviously the NVMe journal is sort of absorbing those writes faster. But during normal use, once you get more IO, more queue depth, it pretty much levels out, and it's actually okay. And the only other thing is spare memory is no longer used as a read cache. Although I'm looking into this at the moment, I think there may be some form of tunable to use some as a data cache. Although if anyone's got any thoughts on that, that'd be good. So really, my thoughts are on mixed hard drive and SSD nodes. Is I think where in comparison to FileStore, where if you had the journal, you didn't really need a RAID controller. I think with BlueStore and hard disks, a RAID controller battery-backed cache really makes a massive difference due to the sort of the latency of writes and the coalescing of I/O, and whether that should be more pushed as a recommended hardware when people are designing. Also, so I was thinking, could the deferred write threshold just be increased to cover some of these slightly larger writes? But I don't know how well does BlueStore handle pushing more I/O through into the database. Larger writes more frequently of them. Do we get back into the situation where SSD wear becomes a problem again? And as I sort of mentioned on the first slide, is this won't apply to new objects. So in cases maybe for like Cephfs, or if you're copying new data into an RBD, you're probably still going to hit this same performance. One thing I did think might be the savior though was using the cache tier and write back, but it seems that new objects get written to the backing pool. So if a new objects get written, instead of getting into the cache tier and then getting flushed down later, it gets written directly into the backing pool. I suspect there might be a simple if that can be added somewhere, or maybe with a variable to control that somewhere in that function I listed there. But I don't know what the correct thing to be looking for to say, does this object not exist? So write it directly to the cache. I guess it's just something to disable the proxy write behavior for new objects, but I'm not 100% sure. If anybody's got any thoughts into that, it'd be really handy. And that's it. If there's any questions.
Maybe one question for you, Nick, is when you were diagnosing the write performance between 64K and 512K, how did what kind of diagnostics did you do, or kind of what kind of behavior did you see when you were looking at that?
So what I'm basically saying is anything under, I think I can't remember if it includes 64 or it's like 63 and under, that gets deferred into the BlueStar DB and then flushed out later. Anything above that size, the I/O gets directly written to the block device and doesn't return like an acknowledgement until that is complete. So on the case of a slow disk, that means the latency of the write sort of greatly increases.
Did you try playing around with the values at all to see if it changed things or?
Yes, I would need to confirm this, but I'm pretty sure if I increase the deferred write, that seemed to cope with whatever you set it to, it would defer it. I just don't know what the impact of the sort of the BlueStore internals of doing that is.
Yeah, exactly right. There's a lot of knobs to play with and a lot of things that you have to worry about.
Yeah.
Okay. For large writes, was file store? It looks like you were testing specifically with an NVMe journal in all cases. Is that right?
That was the cluster has got NVMe journals. So
Okay.
as I said, if you sort of like artificially say, right, I'm going to write one 4 meg object QDEP sort of one, then yeah, you can write into an NVMe journal really, really fast.
Yeah.
If you start to, we've got 12 disks with one NVMe journal. So at that point, if you actually start having all the disks doing I/O, it sort of levels out.
Okay.
And typically what I'd see that if anything's coming in as a 4 meg I/O, it's probably, like a page cache somewhere, something flashing, so it's not synchronous. So it's not an issue.
Okay. And yeah, of course, what you pay for there, right, is that you're just hammering your NVMe drive. So, like you said,
Exactly.
it makes sense that the wear leveling probably looks or your wear statistics probably look a lot better in BlueStore. I would guess.
Yeah. I mean, that's why I was really interested with the caching, because I thought that would almost help in a lot of cases, because it would be hot objects would be going to the cache tier. New objects would be going there, and then everything else, including recovery, probably wouldn't be hammering. So it would be a sort of a midway point between the wearing your SSD and getting the performance.
Sure. All right. Well, yeah. I don't think I have any disagreements with what you said. It all seems like maybe it supports other things that we've seen in the past. So, good job. I'd be curious to hear more if you keep testing it.
Yeah. Okay. We'll do. Yeah.
Cool.
Mark, do you think any of your recent caching work would affect any of these results?
Well, my stuff doesn't make anything faster. It just makes it so that it can, make better decisions about theoretically, what memory to assign where, right? So it might be that you could get, a better hit rate on O nodes in BlueStore or, OMAP data in RocksDB, or even just having memory left over for data for like read cache. But I think we would need to be really careful to make sure that once we start giving lots of memory to the buffer cache in BlueStore, that it doesn't make like trim events start being really slow or something, which is I think maybe the concern, especially if you do default buffered write, if you set that to be enabled. But we probably need to look at it again.
Sure.
Does that make sense, Josh?
Yeah, that makes sense.
Okay.
Just to clarify on this, the sort of the workload on this is sort of measured in the hundreds of IOs. It's not. I think probably what you're looking at, Mark, is when you actually start really hitting things hard and you start saturating several other components inside BlueStore. But this is more about the underlying device latency being exposed through to the client.
Yeah. Like with hard drives like this, you might be able to get away with enabling the default buffered write on the BlueStore side, so that stuff just goes into the buffer cache like immediately. And since your writes aren't that fast, relatively aren't that fast, the you might not hit the mempool thread too hard, because that's where all of those trim events are happening. And I've actually seen the mempool thread basically topped out at 100% CPU doing trim before. I don't remember exactly what the workload was, but yeah, it's that would be the thing to, I guess you'd want to make sure to be careful about. But in this case,
Yeah.
I don't know that would hurt you too bad.
Yeah. Okay. Sure. Okay.
Cool. All right, let's unless there are any other questions. All right,
Is
Adam.
Radix actually there? I was curious about the new objects deferred write thing. That didn't sound right to me.
Okay. I could be wrong. Just from what I've seen, and I think I also read somewhere, is that it sounds like it's the behaviour, but I'm happy to be told otherwise.
Well, no, I'm not
There-
disputing what you're seeing. It's not. I didn't think that was supposed to happen, and Radislaw actually broke some blue store, but maybe he's away from it, stepped away. I wondered if you might know.
I seem to remember that there was quite a bit of discussion about this topic like a year and a half ago.
All right. Well, I guess we lost him anyway, so we'll have to follow up on that.
Blue Store? I'm kind of looking at this first part of that.
That's what I heard too. Did you say broke Blue Store, Greg?
No, Rogue works on.
Oh.
Oh.
But sometimes both can be true.
Hey,
Both
Radek.
can apply.
Radek, do you remember with deferred rights what the path looks like there these days?
Well, I've never known, so no.
Radek, I meant. Sorry.
Well, I don't.
Yeah, it's I've looked at it a while ago and it's really complicated and I don't remember under what scenarios I guess I don't remember how it works, I guess is what it comes down to. All right, Nick, I think Sage is the person to answer your question. Because
Okay.
he wrote almost all of it and he probably remembers best what state it was last in. So we'll maybe we can follow up on the mailing list.
Yeah, I'll try and put something together and send it out. Yeah.
Cool. All right. Adam, why don't you take us away? Let's talk about ASIO and all of your exciting work.
Right. Well, only half of it is my exciting work. The other half of it is Casey Bobby's exciting work. It was going to be using the ASIO-fied Liberatos interface to make the Rados gateway fantastic and wonderful and low latency and all those nice things that we hope for. So first, a brief introduction to what ASIO is. ASIO is an asynchronous networking and I/O layer. It is more networking than it is I/O because non-blocking I/O under many Unix systems, especially Linux, is horrible and garbage and awful. But that's okay because we're a network system. And basically its pattern is what's called a reactor. You submit a bunch of requests. The requests come along with completions, and the completions can get executed in one of various pools. Basically, every ASIO using application is going to have an I/O context, which is sort of the big up top thing that manages all the resources and has a reasonably large thread pool associated with it. And you can have sort of sub contexts, executors associated with that. This is actually one of the ways that they get around locking. They have sort of an abstract executor that you can use if you would prefer to sort of take a more asynchronous route than taking and dropping mutexes, called a strand, which basically just guarantees that while the strand exists inside the thread pool, like it can be run on any number of any one of the threads, anything in the strand is going to be executed at no other time. Well, like when you have a strand, all the things executed in that strand are only going one of the. All right, let me rephrase that. Only one thing that is scheduled on the strand is going to be executed at a time, even though where a task in the strand is executed may vary in terms of threads. So you can sort of think of it as a logically enforced single thread of execution. So if you are so inclined, which I am, you can remove a lot of explicit locking that involves waking threads up and putting them back to sleep and all that stuff, and rephrase it in terms of actions, which are basically scheduling critical sections on strands, just sort of throwing them off that way. So you make better use of your CPU that way and have fewer threads clogging everything up and all that other nice thing. Actually, the reactor design works well in general for the purpose of having fewer thread pools and fewer threads in general lying around. I know that we have in the past had lots of threads and maybe used more than we would like to, and would be interested in using less of them. And this is actually one way of going around that. Basically, the fact that you can have prioritized or other organized sub queues and sub executors inside any given thread pool basically means that we can probably subsume a lot of various work queue functionalities into this model without having to devote explicit thread pools to all of them. One of the, basically among several things that you basically get for free in this model without having to work on them is basically all your timers can go in here. You no longer need an explicit finisher. You just chunk things onto the thread pool or onto the reactor. There are a couple different ways of doing it. Defer basically specifically requires that what you're doing now finish up and get done with before whatever task you had scheduled is allowed to run. Let's see. And a lot of basically sitting down, making a condition variable, waiting on it, waking things up, et cetera, et cetera, et cetera, is really not a thing that needs to happen anymore, since all of that can be subsumed into the whole completion notion. Completions are also nice in that they create a very, very, very easy way of turning asynchronous operations into synchronous operations. And the APIs that I was looking at, after I give you the overview of ASIA, in the API I had been looking at designing, I found myself not actually wishing for synchronous versions of functions, because when I wanted to use something synchronously, it was ridiculously easy to just pass in use future as the completion type
token.
Yeah, completion token. Pardon me. As the completion token, and that just gives me a future that I can wait on, bind tuples to, all that good stuff. It's very nice. It's very natural. It also works very well with coroutines, which I have not actually used all that much, but Casey has, and I'm sure he'd be very, very happy to tell you about coroutines in general. So, my part of the project basically has two goals. Essentially, because Casey was blocked on waiting for one of them, I have been focusing on that one. And also, it's the one that requires the least debugging effort, so it's the easiest to get out of the way first. So this is sort of a two-part thing. One is that we would like a version of Liberatus, and this is a version of Liberatus. It is not, as some people have feared, just opening up the object here to anyone who wants to look at it. It is nicely type erased and hidden away and all that stuff. But our goals were basically that we wanted something that was sort of natively asynchronous and natively integrated into this library with a minimum of overhead. We would like to avoid doing as many allocations as possible. Currently, we do a few more allocations than I would like, and I think we can cut that down without changing the exposed API too much. I just wanted to hurry up and get something that people could work at, and I sort of have a plan to do that later on. let's see. So we basically, so we wanted something natively asynchronous, and we wanted something that didn't allocate all that much. We wanted something that sort of exposed higher level features more easily, like looking at RGW and so forth. We basically wanted to have an easier, nicer way of handling things like namespaces, locator keys, that sort of thing, without necessarily having to spin up the very heavyweight object that the Liberatos IO context is. Also, we were able to sort of save and gain a few efficiencies just by making this sort of experimental interface C++ only and not really worrying about C. So we have less in the way of requiring dynamic allocation for various stuff. And we get to do a whole lot more, make it possible to do a whole lot more just on the stack as a result of that.
Well, as well, we were hoping to unify all of the different thread execution contexts in RDW into one unified. At least that was my.
Yes, that is enough.
All these other things are true too, but that's that was the top level one, I think. Wanted to have one common execution context for requests for dealing with all of its asynchronous states and synchronous states.
Yes, that is basically the thing that unifying this in terms of ASIO does. That since we're using ASIO, and because ASIO has this lovely reactor model which subsumes so many other things, we are able to, as Matt says, have one reactor to gather things all together, herd them along, manage them, and we don't have to have gigantic thread pools. Well, okay, we only have to have one gigantic thread pool. We don't have to have a gigantic metroplex of thread pools. And that we have. That basically the new interface and all that stuff gives us right off the bat. Because at least in sort of the Libratos Unleashed, as I've been calling it, for lack of a better name, although we can change that very easily. Since the user passes in an IO context that is bound to whatever threads he wants, the user can stick all sorts of other things on it and whatnot. And Casey will probably explain some of that design since he's been looking at Beast and how to go about making better use of it. The secondary goals for me were to take advantage of some of the efficiencies provided in improving the objector. Some of that stuff I actually ended up not getting into this pass because I actually really wanted to get the design, sort of the API design space done, since that's what other people were waiting on. And also, I ended up using much more time than I wanted to, sort of in exploratory programming, partly because this is a new model and we were getting used to it, and there are a couple false trails, partly because initially I made the mistake of trying to unify this project with various goals we've had of trying to use context star less and spreading sort of the new interfaces through the rest of the software. That turned out to be a really, really horrible idea because it made doing small, pervasive rewrites of everything my responsibility and debugging them. And this ended up consuming a whole lot of time and was just an awful idea. So everything is now much more backward compatible, and you can just pass in context and everything just works and all that nice things. I do not end up having to. There is no rewrite the world flag day in this model that I ended up converging to for my own sanity. But some of the things that we are hoping to work for is, as I've said before, taking advantage of being able to use functional objects to possibly allocate less memory depending on the size of the object. Especially for smaller things. Obviously, we still want to allow sort of more beefy stuff to go on the heap if it has to. Given that we've had things like good amounts of contention on things like the OSD session locks, I have been looking into the potential to replace much of the OSD session lock work with a per OSD session strand, so all those sorts of things, and what depends on them can basically just be scheduled into the reactor in a way that they're guaranteed not to interfere with each other, rather than waking up and going to sleep over and over and over again and blocking threads. And similarly, I think we can get a reasonable amount of parallelism out of similar changes along that regard. I actually have a couple archaeological / prototype branches with some more of these changes that I ended up pulling out and reverting in the mainline branch, just so I could get the sort of mainline API functionality along. But once I get that debugged and acceptable to people, I'm planning on rolling some of these sort of internal efficiency improvements back in and trying to make them available. So I will be happy to take questions, and Casey can also talk about RGW and his plans for them if he wishes, and depending on the relative order in which he wants to talk and people want to question.
Yeah, if there are questions for Adam, go ahead.
Adam, you were talking about threads earlier, and I was wondering, one of the things, I don't really know that much about ASIO, but I've seen a lot of mentions about using different models for how, if you're using like a single IO service or multiple, like one IO service per thread, and kind of contention at the reactor level too. What kinds of issues have you guys run into, or how have you had to kind of design things?
At the moment, I've been assuming one IO context paired between several threads, which seems a reasonable choice at the client level for the kind of things we're doing. I have not run into any problems with contention from that, although I have not tried anything particularly beefy yet. That if that becomes an issue, it's something we can try to address, certainly.
Yeah, so the model in RGW right now is that the Beast front end owns one IO service, IO context, and spawns a whole bunch of threads to service that one. Currently, the thread pool is the same size as Civet Webs because we're still processing synchronously. But yeah, the ASIO model of the IO context, you can basically create separate ones and service them with different threads. Very flexible that way.
Oh, go ahead.
To break up the synchrony in request processing and yield the threads whenever they would block. And with that, we'd be able to drastically reduce the number of threads that we need, and also be able to share those threads with other background work, such as objectors, completions, and timers and stuff, along with a lot of the other background work that RGW does itself, like GC and other stuff.
That kind of sounds like the model that they, well, not they, but that sounds like it's often used, is kind of having an IO service per thread, and then you have as many threads as you have cores or whatever, and just kind of, spread your work out across all of that.
Absolutely,
that's sort of,
yeah.
That's the thing we can do. It's a bit more C-starry. I don't really have any objection to it, but it sort of requires, I think to make the best use of that, where we wouldn't end up having the same kind of, we wouldn't end up having to ship data between cores all the time, would require sort of a more pervasive change to the API to make it more useful. And it's sort of something that's it's something that works easily, that you can easily do if you're the server and you control the whole application. And it's probably worthwhile as an allowed interface that clients could use if they wanted to. But for something that's, we're basically trying to make a sort of a general use client library, it's harder to dimension that way.
Well, that's an interesting sort of line of discussion. I have to drop for I mean, my goal was certainly to accomplish that, or to a larger extent than, and less about evolving Libredo's parity. So I'm hopeful that once we get a type that, that gets us some way ways in that direction. We can via profiling and other things try to evolve it towards what performs best. There's a lot of variables.
Yeah.
I mean, when you start talking about minimizing the threads per core and other things, so I can certainly understand wanting to defer it, but the API stability of Libretos was not the goal. That creating an interface.
Oh, it's not API stable. I mean, this is a completely new API. It's just that kind of thread per core thing is like a very large change, and without sort of a compelling push in that direction where where there's sort of a neat and natural partitioning, it didn't seem worthwhile to try to develop that particular design until we had one. It's something that we can certainly add very easily on top of what we have.
Yeah. So the thing that I like about these abstractions is that completely up to the application to define its own threading model. And things like objector, all they need to know is an IO context, schedule their completions on.
Yeah, I mean, I think the intent really is for Rados Gateway and its use of these services to undertake that. That was
like at present. There's really nothing that.
Well, that's why this design competed against, for example, using ProxyGen or something along those lines. If it, we don't want to use these in the longer run. We don't want to use this interface the same way we were using Pivot Webs before.
Right.
It would sort of be pointless.
I mean, at present, we can certainly do what Casey is talking about and simply give Objector. Like at present, it's difficult to avoid since Objector initiates events of its own, like hicks and whatnot. It's difficult to tell Objector which IO context to use for every operation because some of the things are going to be internal. But nothing stops us from having one object per core. We can certainly look at trying to replumb Objector in such a way that we can give it multiple IO contexts and sort of direct it in that way. Like if we have an internal sharding we want to enforce across cores, that's something we can add.
As you guys are looking at this, I'd be curious. I went back and I was just browsing some threads that I'd read earlier about people talking about the reactor and ASIO. And one of the things that I remember coming up was someone had done some profiling on their code and saw that a large portion of the instructions were spent on locking and unlocking by the IO service poll function. So it might be interesting to find out if you guys see that in your current design or not.
Oh, we can take a look for it.
I think that argues for getting this is as we discussed last week. This is the same theme. Getting this fully plumbed in RGW, getting a first cut of a work model for it in place, and then indeed profiling.
Well, maybe should we move over to Casey's side of this?
Yeah, I don't have a ton to add to that, but from the RGW side, Adam talked a little bit about strands, which are basically kind of serialized executions. Even though they can move around threads, only one thing happens at a time. And the coroutine model of ASIO is kind of built on top of that. I mean, you can effectively only suspend once and then resume later when the completion comes back. So you only have one thing in flight at a time. And a cool optimization of strands in ASIO is that they have a recycling allocator. So any time that you do an asynchronous operation that needs to allocate something, it can basically just keep recycling memory because it knows it only has to allocate one thing and then give it back and then allocate the next thing. So that's a really good way to minimize allocations from the asynchronous model. And I mean, that gives us kind of an incremental approach to take in RGW. Things are synchronous now. We can kind of add coroutine suspend and resume along the way and eventually break it up into more asynchronous pieces. And then once we get there, we can do everything async and reduce the number of threads. I don't think I have a lot more than that. The RGW stand-up is in about 5 minutes, but I'm happy to take questions.
I guess a question building on what Matt just said, kind of how close are we to having something we could like test and profile?
Have the API part more or less complete, although I need to make a couple more changes to that just to fix a few bugs and get it to pass quality assurance. After that, I mean, we're hoping for our goal is to have something sometime in November. RGW full, I believe.
Cool.
So Adam, how interesting do you think it would be to run some benchmarks on your code as it is that just target that new Librados interface?
Potentially interesting, although there are a few things I need to fix up before that'll work.
Have you done any kind of kind of real early on benchmarking, or do you have any kind of idea of whether or not anything seems faster or slower? Or
A couple of the small micro benchmarks I've tried, just sort of in a hacky way, seemed a little bit faster. It might be because we were spending less time on the allocator, just up and down the call path. I think not having to, like I said, do quite as much allocation right up top helps us a bit.
cool.
Yeah, what sort of workload model is implied there? Bench or other?
Some of the ones that I were doing were simply just a matter of trying to just look at the overhead of consing up operations and dispatching them without even worrying about round trip. And just the consing up and dispatching part, we seemed to do better in. Round trip would require more instrumentation on both ends. Interfering everything else.
That seems like a good area for suggestions. I mean, if you Mark and Radislav, other people that are interested in micro benchmarking of the APIs, have some thoughts as to how we ought to activate it, or continue teaming up with that in that area, that could be useful. Sounds like. Now I've been interested in sort of as we were discussing last week in sort of whole program profiling of the RGW process. So I think that's a key piece that our team wants to do. And might overlap at might at a large scale find things that are of general importance and cross over at some point. But I'm less interested in micro benchmarking the Librados API than I am in that sort of whole program result.
Yeah. Yeah, I think maybe Adam, once you've got your fixes done that you want to implement, it would be interesting to look at. And I am really curious.
I mean,
go ahead.
Ultimately, one of the things that we had considered is trying to adapt the direct messenger work to basically create a dummy sink for the object to plug into, so we can basically test the entire client pipeline.
That would be good.
A near-term goal for how to try and do benchmarking.
That does sound interesting.
One of the things that I haven't done probably enough of is look at that whole side of the stack. I mean, we've pretty intimately benchmarked the OSD and at least have some idea of, well, I mean, Radek has also done this, and so has Adam and multiple people. I think overall we've got some idea of kind of what skeletons are in the closet and what things are not great. On the client side, every time I've looked at it, I've been surprised by things, and I promptly forget them and probably re-surprised again. So yeah, it'd be good to probably look at it closer.
Yeah, clients are terra incognita, so taking a look, it's something we don't really know from the profiling point of view. Really great to take a look.
Yeah, I think that Jason Dillerman has done some work there, and so I would really like to have him in the conversation of how to measure this and make sure that it's actually performing better than what we have.
Yeah. Yeah, the only thing on the client side that I really remember is how crazy RBD cache how much of an impact that ends up having on fast devices, because it was kind of dominating everything else when it's enabled in a bad way in the NVMe case. But yeah, otherwise I don't actually remember what exactly we saw on the client side. Maybe some locking.
Okay, well I have to drop too.
All right. Well, let's wrap it up then. Uh, good work, guys. Very interesting project.
Thanks, Mark. Bye-bye.
Yep. See ya.
Thank you. See you. Bye.
All right. Well, anything else from anybody, or should we wrap it up for today? All right. I see people leaving, so I think we're done. Have a good week, guys.